Hello everyone, today we are learning lesson 13.3, day 2, and that is the base e. So we are continuing to work with functions dealing with the base e for exponential growth. And we are going to also be doing triad problems throughout the lesson. Let's take a look at the review of the reference points. So given an exponential function with the base e, we know the reference points are 0, 1, and 1, comma, e. So notice that those line up with these once the transformations are applied. And so let's make a note that today we're only going to be using the right-hand side for the reason that we know that base e is always going to be e, so we don't even need to find the base. And we basically need to solve for a, h, and k, and we're squared away with the equation. So when we are writing the equation, we only need to find 3 variables for the function with the base e. And so with this second coordinate right here has everything that we need. So let's keep that in mind. Let's take a look at the first example here. And the first example has a graph, and we need to write the function. So we know that the horizontal asymptote is going to be somewhere over here. And so based on this first point, it is mapped up with h. So we know that h is actually equal to -1. So that's the first thing that we can see. H equal -1. Remember, we're looking for h, k, and a. Those are the 3 variables that we need to get the equation. Next, we're going to take a look at the second coordinate in the second graph. And remember, that maps up with AE plus K. So we're going to line it up with AE plus K equals -2E minus 3. And so from here, because we know that E's are lining up, so those are equal to each other. So therefore, we know that A must equal to -2 from the equation, and that K is also lining up to -3. And therefore, we have our values that we need to make our equation. So the general equation for the exponential is f of x equals a e to the x minus h plus k. So let's substitute the numbers that we have just obtained from the equation, the graph. A is -2, e is the base that is given, x minus h, that's a -1, so it's a +1, and then k is -3. So let's go ahead and write down that -3. And the last thing we probably want to do is identify the domain and range. So we know that the domain is still all reals for any exponential function. And the range is going to be, since this graph is lying below the horizontal asymptote, it's going to be y less than the horizontal asymptote is -3. So that's y less than -3. And that would be the answer for this problem right here. So go ahead and pause the video at this time and try the next problem before you look at the solution. So hopefully you've had a chance to try the problem. And again, we're going to find the equation for the graph of this exponential function. And we can tell that the horizontal asymptote is somewhere over here. And the first point that is closest to that will have the h value of 9. So we have h equals 9 right away. And the second point, we're going to use this second coordinate, the y coordinate of the second point. So we will have AE plus K equals 3E plus 4. And again, the E's are lining up, so we know that A is equal to 3. And then K is lining up to 4. So we have K equals 4. So putting that all together into this general equation, again, A e to the x minus h plus k, we have f of x is equal to 3e to the x minus 9, and then k equals 4. So that's a +4. Lastly, we probably want to identify the domain is all reals, and the range is the graph is lying above the line y equals 4, so it's y greater than 4, and that is the complete answer for this problem. Hopefully you got it right earlier. And here's another opportunity for you to try and find the equation for this graph right here. Again, we already have the horizontal asymptote, which is given by the equation y equals 1. So we know that k is actually equal to 1 right away. And the point that's closest to it is going to be here. And so we can tell that h is also equal to -2. So we got 2 out of the 3 values. Well, great. We've only got one more to find. And let's use that second point, the second coordinate. So let's again map up a, e, plus k and set that equal to 1 minus e. Now notice that the e and the 1 are kind of in the wrong position. So we're going to rewrite that as -e plus 1. So that way we can have the e's line up first. And now we can easily tell that a is equal to -1 and k is equal to 1. So with that said, we're going to fill out our general equation, a e to the x minus h plus k. Again, substituting the number, a equals -1, so that will be negative, and that will be x. H is -2, so that will be a +2, and k is 1, so that's a +1 at the end. And the domain is going to be, again, all reals. The range is y. Y is below this horizontal asymptote, so it's less than 1. And that would actually make sense for this graph because notice the graph is flipped. So instead of an exponential growth looking like this, it is flipped because of that negative in front. So that is the answer. Next, let's take a look at the real-world problems working with interest. So we here introduce to you a new equation. Whenever you see the keyword continuously, everyone, we are dealing with the equation A equals PERT. Notice PERT is A equals principal times e to the r times t, where r stands for the rate and then t is the time. And so let's take a look, and t is also always expressed in years. So easily you can remember this formula as A equals PERT, and again it deals with the magic word continuously. So let's use the formula to find the first equation. Use the formula to compute the balance of an investment that had a principal amount of $4,500 with a 5% interest rate and then 6 years. So here we have A is equal to the principal, which is $4,500, times E to the 0.05. We're going to convert the interest rate into decimal here, times 6 years. And go ahead and use your calculator to find the answer. And you should have an answer of 6,074.36. Don't forget to verify that with your calculator. And that is the amount is in the bank after 6 years, earning 5%. And B, what is the amount of interest earned in the investment? So that would be the final total minus the original amount, and that will give us a interest of 1,574.36 cents. And that is the answer for part B. And let's take a look at the next problem. When interest is compounded again continuously, the amount A is given by the formula. So it's just describing that this is the formula you need to use, where P is the amount of the principal and R is the interest rate. Ms. Ho has a choice of 2 investments and they are both compounded continuously. She can invest in $12,000 at 5% for 8 years, or she can do $9,000, 6.5% for 7 years. Which investment will result in the greater amount of interest earned? So I hope that you pay careful attention to this problem because that may very well be a quiz or a test question later. So hopefully you guys will remember how to do this. So first, we are going to calculate the interest for Ms. Ho's first investment, which is at $12,000 principal. Because it's continuous, we're going to use the PERT formula, and that will be E to the 5% is 0.05 times 8 years, and that will give you a total of $17,901.90. And the interest that she earned here is going to be 17,901 minus the 12,000. That's going to be the interest earned 5,901.9. And the second choice is going to be principal amount 9,000 e to the 6.5, 0.065 times 7 years. And that will give us approximately, they are both approximate, 14185.56. And that would be the dollar amount after 7 years. The interest here is going to be, again, taking 14185 minus the original of 9,000, which is going to give us the interest of 5,185.56. So which one investment will result in a greater amount of interest earned? Well, the answer is pretty clear. The first investment, A, is going to give us a higher interest. And so that would be, but let's talk about which one would be a better investment choice. We are looking at the interest rate. That would be 5% versus 6.5. So a better choice for investment is probably the second one because you have a higher interest rate. So even though it's less because it's less amount of time, but it's still doing better than the first one, I think, because of the interest rate that is higher. And that would be a wrap for this lesson. Go ahead and get started with your assignment, the book set, HRW, copy notes for next day, and don't forget Alex. Have a nice day.